Hello everyone, I am Balaji Rao. Welcome to BR Maths class. Now you can join in the batch JEE Mathematics 2026. Course link is given in the description. This is last class in relations objective part. Actually, this is scheduled on 1st March. It is delayed one day. These are the chapters we completed. In basic mathematics, all these chapters we completed. Sets, complete NCERT, sets, complete objective, we completed. Relations, class 11th relations, class 12th relations, complete NCERT, all the solutions we did, just like a one-shot video. You can check that. Around 4 hours video is there. Relations, we did it in two parts. This class is all about relations objective. Next class is scheduled on 5th March. This functions NCERT part, we'll do it in two parts, like class 11th functions, class 12th functions. Then immediately we'll start objective related to it. In this relations second class objective, what are the things we covered? First, we did problems which are given in 2025 related to reflexive relation, symmetric relation, transitive relation, equivalence relation. See, one more question on reflexive, symmetric, transitive. See, another question given in JEE 2025, question given in 2025 on reflexive, symmetric, transitive. More questions given in 2025 based on relations. All 2025 questions covered on relations. Next, we covered the problems based on domain, codomain, range. See, 2025 question given in based on range of a relation. All these problems we covered in this video. All these classes are completely free on YouTube. You can find the playlist of all these chapters. However, without ads, without advertisements, if you want my classroom notes, practice materials, you can purchase this course for a very nominal price. In this video, for every topic, for every question, timestamps are given. I strongly recommend you to watch these videos with a speed of 1.5 to get good experience. Before going to start this video, please drop a like for this video. If you like the content, please share it with your friends. Without much delay, let's begin the class. This is the question given in JEE examination. See, before starting this question, what I request you, first this video, you already know what is reflexive relation, symmetric relation, transitive relation, equivalence relation. We already done few problems, PYQs also we did. I request you to pause this video, try your own. If you get the answer, check my solution. If you didn't get the answer, then also check the solution, because methods may vary. What method I do, what method you, what idea you will get, that may vary sometimes, right? So first try your own, later check the solution. When you try your own, you will get clear idea about the question also, right? Now let's see the solution. They define a relation R on this set. R is a relation on this set. What way the relation is defined? X is related to Y. That means the order pair X comma Y belongs to R. When order pair X comma Y belongs to R, when secant square X minus tan square Y equal to 1. Whatever xy values are there, if they satisfy this equation, then X comma Y belongs to this relation. X is related to Y. I hope you understand this. When we say Y is related to X, as per this, when we say Y is related to X, Y is related to X means Y comma X belongs to R. When we say Y comma X belongs to R, Y is related to X. Observe here, we say Y comma X belongs to R when secant square Y, please observe, secant square Y minus tan square X equal to 1. If secant square X minus secant square Y minus tan square X equal to 1, then we say Y is related to X, or we say Y comma X belongs to R. I hope you are understanding, right? When we say X is related to Z as per this relation, X is related to Z. If secant square X minus tan square Z equal to 1, then we say X is related to Z. I hope you understand this, okay? This knowledge is minimum needed to solve this problem, okay? Right. So you understand the given relation. Now you observe reflexive, transitive, not symmetric, equivalence relation, like that they given. So one by one we will check. First, what I'll do, I'll check reflexive. Here, what are X and Y? X, Y, relation is defined on this set na. X, y lies in this interval. X value you can take any number in this interval. Y value also can be taken any number in this interval. Okay, reflexive relation. When we say this relation is reflexive, x is related to x or y is related to y, right? For every, I'll write here, for every x belongs to given set, closed interval 0 comma pi by 2, secant square x, when x is related to x, you tell when x is related to x, secant square x minus tan square x equal to 1. Then x is related to x. So come back to the trigonometry, right? You know this formula, very popular. What is that formula? 1 plus tan square x equal to secant square x. From this, secant square x minus tan square x is what? Secant square x minus tan square x is 1, right? This is true for all real x. Not only this, for all real x, secant square, this is identity, trigonometric identity, right? This is true for all x values in its domain, right? So 1 plus tan square x equal to secant square x. Secant square x minus tan square x is 1. We know this. So here reflexive relation, how you will check? I need to check x is related to x or not. When x is related to x, secant square x minus tan square x is 1. Then x is related to x. Actually, this is identity. This is true for all real values of x in its domain of the function. That is important. Domain of this function, right? So secant square x minus tan square x is true. So what I can say here, you take any x in this interval, secant square x minus tan square x is clearly 1. When secant square x minus tan square x is 1, then we know x is related to x. That can be written like this or like this. X is related to x or x comma x belongs to R. So this relation is reflexive relation. So I am not writing all the things here. I'll just give a tick mark here. This relation is reflexive. Okay. Now symmetric. This relation is symmetric relation or not. How to check the relation is symmetric relation or not? First we'll take x is related to y. I'll take x is related to y. Later I'll check y is related to x. That is nothing but I'll take x comma y belongs to R. That means x is related to y. When x comma y belongs to R, what I can write? I can write secant square x minus tan square y equal to 1. Okay. Now what I need to check? Y comma x belongs to R or not. That means y is related to x or not. When y is related to x, secant square y minus tan square x equal to 1. Secant square y minus tan square x equal to 1. Then I can say that y is related to x. I hope you are understanding, right? Okay. So here I'll check secant square y minus tan square x. Secant square y. Here secant square y is not there, but tan square y is there. Tan square y I can write in terms of secant square, right? Let's see. See here the secant square x is there now. From trigonometric identity, you see this trigonometric identity. Secant square x can be written as 1 plus tan square x. So in place of secant square x, I'll write 1 plus tan square x. Okay. This secant square x can be written as 1 plus tan square x. Okay. This tan square y, this minus tan square y, you take it to the right hand side. Then what it will become? This will become 1 plus tan square y. From this trigonometric identity, what is 1 plus tan square y? 1 plus tan square y is secant square y. Okay, this implies 1 plus tan square x equal to secant square y. Now you take this tan square x to this side. Okay, what you will get? Secant square y minus tan square x equal to 1. What I am trying to prove? I am trying to prove that y comma x belongs to R. When y comma x belongs to R, y is related to x. That means secant square y minus tan square x equal to 1. I got the same thing here. Secant square y minus tan square x equal to 1. From this what I can say? I can write that the order pair y comma x belongs to the relation. Therefore, this relation is symmetric. I'll keep tick mark for symmetric. At this point, with the options, can we declare the answer? You see here, this relation they are saying it is not symmetric, but it is symmetric. So we can eliminate the first option. Okay, they are saying this is neither symmetric nor transitive. We can eliminate this option also. Equivalence relation we cannot decide now because it is reflexive symmetric. We need to check transitive. Both reflexive and symmetric but not transitive. No, you cannot find the option. You need to check transitive condition also for this. Okay, I'll check transitivity. For that what I'll do, I'll take x is related to y, I'll take x is related to y and y is related to z. I take two order pairs in the relation like this. When x is related to y, secant square x minus tan square y equal to 1. If y comma z belongs to R, secant square y minus tan square z equal to 1. Okay, secant square y minus tan square z equal to 1. Good. What you want to check? You want to check x comma z belongs to R or not. When x comma z belongs to R, when secant square x minus tan square z equal to 1. So I'll check this secant square x minus tan square z is 1 or not. Okay. If secant square x minus tan square z is 1, then I can say x comma z belongs to R. This relation is transitive. So secant square x minus tan square z. You take secant square x minus tan square z. You observe here secant square x is there. Now secant square x can be written as 1 plus tan square y. Right? I can write, yes. In place of secant square x, I'll write 1 plus tan square y. Okay, minus tan square z. Tan square z is secant square y minus 1. Secant square y minus 1. Yes, I can write secant square y minus 1. Good. Now you observe this minus of minus is plus, right? So 1 plus 1 is 2. Okay. 2 plus tan square y minus secant square y. You know this identity. 1 plus tan square y equal to secant square y. Okay. I want what is tan square y minus secant square y. You take this to this side and you take this 1 to this side. Then what you will get? Secant square y you will get tan square y minus secant square y equal to minus 1. It can be understood easily. Tan square y minus secant square y equal to minus 1. So in place of this tan square y minus secant square y, I can write minus 1. So 2 minus 1 is 1. So what I got here? I got secant square x minus tan square z equal to 1. From this, what I can say? I can say that the order pair x comma z belongs to R. So for x comma y comma z belongs to R, I got that x comma z also belongs to R. So this relation is transitive. So this is reflexive. This relation is reflexive, symmetric and transitive. So what is the right option? In the question they given, it is a equivalence relation. This relation is equivalence relation. So second option is the right option. See, as per JEE standards, this problem is easy problem. Whoever the batch they got this question, they are lucky actually. Right? Easy. Only just if you know this trigonometric identity, 1 plus tan square x equal to secant square x, then you can do it. Right? You see, this is the question given in 2025. How the relation is? R equal to order pair x comma y. X, y both are integers. That means R is a relation on integers. X plus y is even. A relation is clear. R is a relation on set of all integers. Order pair x comma y belongs to R if x plus y is even. Suppose my question is 2 comma 3 belongs to this relation or not. See, for every problem I'll say one thing. First try your own. Okay. Now see 2 comma 3 belongs this relation. When 2 comma 3 belongs this relation, both must be integers. Yes, 2, 3 both are integers. 2 plus 3 is what? 2 plus 3 is odd. 2 plus 3 is 5. 5 is odd number. So when x comma y belongs to R, when x plus y is even. So 2 comma 3 belongs this relation? No. Why? Because 2 plus 3 is odd number here. 2 comma 3 does not belongs to R. See 2 comma 4 belongs this relation. 2 comma 4 belongs this relation. 2 4 both are integers. 2 plus 4 is 6. 6 is even. So 2 comma 4 belongs to this relation. What about 5 comma 5? Both are integers. 5 plus 5 10. 10 is even. Minus 2 comma 4. Minus 2 comma 4. Add both. Minus 2 plus 4. That is 2. 2 is even. So both are integers and sum of them is even. So this minus 2 comma 4 belongs to this relation. First of all, you must know which order pair is there in the given relation, right? Okay. So here they are saying reflexive, symmetric, not transitive, something like that. So one by one, I'll check reflexive. First, I'll check reflexive. When we say this relation is reflexive, if x comma x belongs to R. So I'll take here for every x belongs to Z, x comma x belongs to R or not, I need to check. When x comma x belongs to R, if x plus x is even, okay, right? X is an integer. X plus x is even or not, you need to check. X plus x is what actually? X plus x is 2x. What is x? X is any integer. It may be odd integer or even integer. X can be any integer. What is 2x? For any integer x, 2x is always even. Try to understand this, please. 2x is even. So what it tells you that x plus x is even. For any x belongs to z, x plus x is even. So if x plus x is even, x comma x belongs to R, right? From this we can say that x comma x belongs to R. So this relation is reflexive. Okay. Now I'll check symmetric condition. It is symmetric or not. What way to check? I'll take x comma y belongs to the relation. Okay. So if x comma y belongs to the relation, what I know, I already know that x plus y is even. Okay. X plus y is even. Now what I need to check? I need to check y comma x present in the relation or not. Okay. When y comma x belongs to this relation, if y plus x is even, I need to check y plus x is even or not. Okay. How to check y plus x is even or not? A very simple thing. See, x plus y plus x for any integers x and y, is x plus y is same as y plus x. Commutative law holds good with respect to addition on integers. X plus y is same as y plus x when x and y are integers. You can check if you want, right? So here y plus x is same as x plus y is even. I'll write here, since x plus y is same as y plus x. That's why if x plus y is even, then obviously y plus x is also even. As you got y plus x is even, from this I can say that y comma x belongs to the relation. So if x comma y belongs to R, for every I'll write here, for every x comma y belongs to R, y comma x also belongs to R. So I can say that this relation is symmetric. So this relation is symmetric. Now transitive. To check transitive, what we'll do, we'll take for any x comma y belongs to R and y comma z belongs to R. Now I'll check x comma z belongs this relation or not. When x comma z belongs to R, if x plus z is even, right? If x plus z is even, I can say x comma z belongs to R. As I have x comma y belongs to R, from this I can write that x plus y is even. As y comma z belongs to R, I can say y plus z is even. Okay. You observe here, as x plus y plus z are even. If we add two even numbers, what you will get? Even number plus even number is always even. If you want, you can check, right? What I'll do, I'll add these two, x plus y plus z. If I add these two, what I'll get? I'll get it as a even. Even means what? This whole thing is a multiple of 2. 2 into some integer, right? I'll write this x plus y is 2y na, plus z. As it is even, I'll write it as 2k1, where k1 is some integer. Okay, right? Now, what is x plus z from this? X plus z is 2 times of k1 minus 2y, right? From this, what is x plus z? X plus z is 2 times of k1 minus y. What is y? Y is some integer. What is y? Y is some integer. You see here, x comma y belongs to R means y is some integer, right? So this is what? This is some integer. So x plus z is what? 2 into some integer. This tells you that x plus z is even. So x comma z belongs to R. So this relation is transitive also. This is reflexive, symmetric, transitive. So this relation is equivalence relation. See, by seeing these questions, you may get clear idea that it is possible you can score 4 marks from relations. Do good number of practice problems. I'll provide practice material also. Please do all the practice problems. You observe this relation 1 comma 2, 2 comma 3, 3 comma 3. This relation is defined on this set 1, 2, 3, 4. This is also question from 2025. However, my request is this type of questions you already done earlier. Pause this video, try your own. Then only your concepts will improve. Later check with the solution. Okay, and one important thing is you will get answer. I'll also will get the answer. What way I am doing this problem, you catch that, so that you won't feel it difficult, right? R is like this. It is defined on this set. The minimum number of elements needed to be added in the relation so that the relation will become equivalence relation. Okay, so first what relation they given, I'll write it. 1 comma 2, 2 comma 3, 3 comma 3. This is the relation. Okay, what are the minimum they are saying? Minimum number of elements needed to be added in the relation such that this relation will become equivalence relation. Okay, actually R is a relation on this set. Na? this A cross A contains 16 elements. A cross A contains 16 elements. Okay. So here already 3 elements already given. They are saying it is a equivalence relation. So to make this relation is equivalence relation, first it must be reflexive. It must be reflexive means for 1 comma 1 must present in this, 2 comma 2 must present in this, 3 comma 3 is there here, 4 comma 4 is not there. So to make this relation reflexive, these are must. 1 comma 1, I'll do one thing, I'll write the relation 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. This element is already there in this given relation. Okay, so these 4 elements must present in the relation, then only the relation is reflexive, then only for other equivalence relation we can say. So here 3 elements I added. In addition to this, in the given relation 1 comma 2 is there and 2 comma 3 is also there. 1 comma 2, 2 comma 3. So whatever I am marking here, they are already given in relation. Okay, now till now I added 3 elements only. To make this relation equivalence relation, it must be symmetric, right? You know that this type of elements always satisfy symmetric condition. No need to check. These are all actually feel happy elements. This element satisfies transitive condition. This element satisfies a reflexive condition. This element satisfies symmetric condition. See, for 1 comma 1, where is the reverse 1 comma 1? No need to check. Reverse 1 comma 1 will be there only. So this type of elements always satisfy symmetric and transitive. No need to check these things. Okay. Now for 1 comma 2, 2 comma 1 must exist because they are saying it is a equivalence relation. For 1 comma 2, 2 comma 1. For 2 comma 3, 3 comma 2. Okay. Now if you observe, this relation is reflexive, this relation is symmetric also. See, reflexive for 1 comma 2, 2 comma 1, for 2 comma 3, 3 comma 2. So this relation is reflexive and symmetric. Now is this relation is transitive? You check here, these elements always satisfy transitive condition. No need to involve these elements to check transitive condition. You look here, 1 comma 2, 2 comma 3. 1 comma 3 is there in the relation. 1 comma 2, 2 comma 3. 1 comma 3 is not there in this relation. So this is not transitive. So it is not equivalence relation. So what I'll do, I'll add 1 comma 3 also. For 1 comma 2, 2 comma 3, 1 comma 3 you written here. Na? To make this relation is symmetric, 3 comma 1 also must exist here. Then only it is symmetric. Okay. So now you check these elements always satisfies transitive condition. Now start from here. 1 comma 2, 2 comma 3. 1 comma 3 is there here. This ends with 2 na. Any other, see 1 comma 2, 2 comma 1, 1 comma 1 is there. Any other starts with 2? No. So we say that this element passed the transitive test. Now come to this 2 comma 3. This ends with 3. You check other than this 4. Any other starts with 3. This starts with 3. This starts with 3. 2 comma 3, 3 comma 2. 2 comma 2. Okay, 2 comma 2 is there. 2 comma 3, 3 comma 1. 2 comma 1, yes, 2 comma 1 is there. Right. So we say this element passed the transitive test. Come to this. This ends with 1. See here. This starts with 1. This starts with 1. You check these two. 2 comma 1, 1 comma 2. 2 comma 2 is there. 2 comma 1, 1 comma 3. 2 comma 3 is there. Yes, 2 comma 3 is there. So this element passed the transitive test. Come to this. This ends with 2. You see, this starts with 2. This starts with 2. 2 comma 3. Sorry, 3 comma 2. 2 comma 3 is 3 comma 3. 3 comma 3 is there here. 3 comma 2, 2 comma 1 is 3 comma 1. 3 comma 1 is there here, right? So this element passed the transitive test. Which element? This 3 comma. Any other starts with 2? No. Okay. Now come to this. This ends with 3. See, this starts with 3. 1 comma 3, 3 comma 2. 1 comma 2 is there here. 1 comma 3. This starts with 3. This also starts with 3. 1 comma 3, 3 comma 2. 1 comma 2 is there. 1 comma 3, 3 comma 1. 1 comma 1 is there here. Yes. This element also passed the transitive test. Come to this. 3 comma 1. This ends with 1. Look here, this starts with 1. 3 comma 1, 1 comma 2. 3 comma 2 is there here. 3 comma 1, 1 comma 3. 3 comma 3 is there here, right? So this relation is a transitive also. This relation is reflexive. This relation is symmetric. This relation is transitive. How many elements we added? 1, 2, 3 plus 4, 7. Total 7 elements. So to make this relation is equivalence relations, how many minimum number of elements are to be added means 7 order pairs are to be added along with this order pair so that this relation will become a equivalence relation. You observe this question. This is given in JEE 2025. This is, you will feel it is bit lengthy. First you see what they given. Set A is 1, 2, 3. Number of relations, they are asking number of relations which contains 1, comma 2, 2, comma 3, which is reflexive, transitive but not symmetric. Here I'll write some data. They given set A. What is set A? 1, 2, 3. Okay. And R is a relation on A. Okay. So what I'll do here, just I'll, to keep one idea, I'll write A cross A. I just written A cross A here. Okay. It is useful, I'll tell you. Actually not needed, but it is useful. Okay, A cross A I written. R is a relation. That relation contains 1, comma 2, 2, comma 3. Okay, this relation contains 1, comma 2, 2, comma 3. Here the question is number of such relations which containing these two order pairs which are reflexive, transitive, not symmetric. Number of relation means here actually how many relations are possible? Number of relations on this set 2 power number of elements in A cross A. R is a relation on A. Na? A cross A contains 9 elements. 2 power 9, that means 512 relations are possible. In those 512 relations, how many relations are there which contains these two order pairs, satisfies reflexive, transitive but not symmetric? Initially you may feel it is bit tough, but actually it is easy. Let me solve this, right? So they are saying it is reflexive. Na? As they are saying it is reflexive, this relation must contains 1, comma 1, 2, comma 2, 3, comma 3. It is must. Then only this relation is reflexive. I'll write here what they are saying. For reflexive, yes. Symmetric, no. Transitive, yes. You need to add some order pairs to this from A cross A such that it is reflexive, not symmetric and transitive. So to make it reflexive, what I'll do first, I'll take this as a R1 relation 1. 1, comma 2, 2, comma 3, these are must. These are must. To make it reflexive, 1, comma 1, 2, comma 2, 3, comma 3. These are must. In addition, whatever relation you take in this example, as they are saying that relation is reflexive, that relation along with this, these three are must. Okay. Symmetric, they are saying. So symmetric means for 1, comma 2, 2, comma 1 is there or not, doesn't matter because it is not symmetric. Transitive, it must be transitive. Now you check, is this relation is reflexive, not symmetric, transitive? It is reflexive, yes. It is not symmetric, yes. Is it is transitive? See, whenever you check transitive condition, no need to check these elements, right? You just check for these elements only. So x comma y comma z. Okay, here this ends with 2, this starts with the 2. So x comma z is what? 1 comma 1 comma 3 is there in this. It 1 comma 3 must present in this because they are saying given examples of a relation which is transitive. So to give an example which is reflexive, not symmetric, transitive, these elements are must in every relation. Number of relations they are asking now. Whatever the relations you will write, in that all these things are must. I hope you are understanding, right? R1 is what? R1 is a subset of A cross A. A cross A contains how many elements? 9 elements. In these relations also, whatever you will write, it contains 9 elements maximum. You won't get any example with relation which contains 10 elements and satisfying this condition, right? So I try to understand whatever relation you write. This is the first relation I am giving. They are asking number of such relations are possible. In that, these things are must. Okay. Now, before adding any other in this, I'll just check that this is a reflexive, not symmetric, transitive. I'll just check it. Reflexive. Yes, it is reflexive. Not symmetric. For 1, comma 2, 2, comma 1 is not there. Yes, not symmetric. Satisfying that condition. Transitive. This type of elements always satisfy transitive condition. You just check transitive condition for these elements only. This ends with 2. This starts with 2. 1, comma 3 is there here. Okay. Any other order pair starts with 2? No. Right. This order pair pass the transitive test. Now you take this 2, comma 3. This ends with 3. Any other order pair starts with 3? No. So we say that this element pass the transitive test. Right. Now come to this. This also ends with 3. Any other order pair starts with 3? No. So this also pass the transitive test. So this is the relation which is reflexive, not symmetric and transitive. One example already given. Now second example. I said earlier these are must, so that relation is reflexive, transitive, not symmetric, obviously satisfying. Okay. Now second example. You keep A cross A in your mind. Now you observe this A cross A, 1, comma 1, 2, comma 2, 3 comma 3, 1 comma 2, 2 comma 3, 1 comma 3. Whatever I marked here, these order pairs already there here, 6 elements, right? Now you just check by adding one by one. You write 2 comma 1 here, right? Just add one more, 2 comma 1. Okay. Now you check it is reflexive, not symmetric trans. It is reflexive. For 1 comma 2, 2 comma 1 is there. Okay, let it be. For 2 comma 3, 3 comma 2 is not there in this. So not symmetric condition satisfied. Now is it is transitive or not, you need to check. These elements always satisfy transitive condition, so we won't check. This ends with 2. This starts with 2. 1 comma 2, 2 comma 3. 1 comma 3 is there here. 1 comma 2, 2 comma 1. 1 comma 1 is there here. Yes. Now take this 2 comma 3. This ends with 3. Any other starts with 3? No. So this element passed the transitive test. Come to this. This ends with 3. Any other starts with 3? No. This ends with 1. Any other starts with 1? Yes. 2 comma 1, 1 comma 2, 2 comma 2, 2 comma 1, 1 comma 3, 2 comma 3. 2 comma 3 is there here. Yes. So this relation is reflexive, not symmetric, because for 2 comma 3, 3 comma 2 is not there. This relation is transitive. So this is the second example. So I added A cross A is there na? In A cross A, you just keep in your mind that I used this 2 comma 1. Here I added 2 comma 1. Now you just check with 3 comma 1. Okay, I'll write relation. Now what I'll do in this here, this 2 comma 1 is there na? That I'll eliminate. And what is the other one here? 3 comma 1. You add 3 comma 1. Okay, now you check. These elements always satisfy reflexive condition. For 1 comma 2, 2 comma 1 is there. For 1 comma 2, 2 comma 1 is not there. So this is not symmetric. We want that example only. Is it is transitive? You see here, this 2 comma 3, 3 comma 1. For 2 comma 3, 3 comma 1, 2 comma 1. 2 comma 1 is there in this relation. 2 comma 1 is there in this relation. 2 comma 1 is not there in this relation. So this is not transitive, but we want it transitive. So you just remove this 3 comma 1. Now you just check with this 3 comma 2. Right? 3 comma 2. Now you check. It is reflexive. Yes, it is reflexive. Is it is symmetric? For 1 comma 2, 2 comma 1 is not there. So it is not symmetric. We want that example only, right? Transitive. This ends with 2. 1 comma 2, 2 comma 3. 1 comma 3 is there. Any other starts with 2? No. Okay. This element passed the transitive test. Now come to this. This ends with 3. See here 2 comma 3, 3 comma 2, 2 comma 2 is there here. Any other starts with 3? No. Right. Good. Now, this element passed the transitive test. Come to this. This ends with 3. Any other starts with 3? Yes. 1 comma 3, 3 comma 2. 1 comma 2 is there here. Yes. Any other starts with 3? No. So, this element passed the transitive test. This ends with 2. You check any other starts with 2. Yes, here it is. 3 comma 2, 2 comma 3. 3 comma 3 is there. So, this relation is reflexive, not symmetric, transitive. Okay. Now you see this 3 comma 2 also added. You observe this 3 comma 2 also added. When I check for 3 comma 1, this relation is not transitive, right? But we want example for transitive relation. Okay. Now what I did actually in this, first I written 2 comma 1, I checked. Next I written 3 comma 1. In addition to this order pairs, I written 2 comma 1 and I checked. It is satisfying the condition. Next, in addition to this, I added 3 comma 1. I checked. It failed the condition. Next, in addition to these elements, I added this and I checked. Now, you take two elements, 2 comma 1, 3 comma 1. If you take like that, they are saying it is not symmetric. That condition fails. That's why if I take 2 comma 1, 3 comma 1, see, in addition to this, I'll write here 2 comma 1, 3 comma 1. If I write 3 comma 1, transitive condition is failed. You already checked that, right? You can check this is symmetric. You can check this is symmetric. For 1 comma 2, 2 comma 1 is there. For 2 comma 3, 3 comma 2. To make it transitive, 3 comma 2 is compulsory. See here, this 3 comma 1, 1 comma 2, 3 comma 1, 1 comma 2, 3 comma 2, transitive. This must be transitive now. So what I am trying to say here, it is a bit tricky only. No doubt it's not going to be very easy, right? These three are the relations which satisfies this condition: reflexive, symmetric and transitive. So number of such relations they are asking na, total 3 relations are there. I hope you understand this solution. See, this question is lengthy, but actually it is easy only. You see, x is R cross R. R is here, you see bold letter, that means R cross R. R is a real number, set of all real numbers. This R is not a relation R. X is on R cross R. And define a relation R on X. R is a relation on X. R is a relation on X. Okay. You see here, A1 B1 is related to A2 B2 if B1 equal to B2. R is a relation on X means R is a subset of X cross X. X is like this, na? X cross X contains what? Two order pairs will be there. Here, see here, 2 comma 3 is related to 4 comma 3. Is 2 comma 3 is related to 4 comma 3. As per this condition, you check here. A1 B1 is related to A2 B2 if B1 equal to B2. You see here, yes, 2 comma 3 and 4 comma 3 are related to each other. Suppose 2 comma 3 is related to 4 comma 5. Is 2 comma 3 is related to 4 comma 5? No. Why? Because these two are not equal, right? Okay, this is the first statement. They are saying R is equivalence relation. Some other second statement is also given. First we will check this statement 1, right? Reflexive. How to check reflexive? You take one order pair, A1 B1. If A1 B1 is related to A1 B1, then we say this relation is reflexive. Is A1 B1 is related to A1 B1? You just check, is it is related to each other. See here, these two are equal. B1 is equal to B1. Obviously B1 equal to B1. So this relation is reflexive relation. Symmetric. Is this relation is symmetric? How to check symmetric or not? You take one order pair, A1. You take one pair of order pairs like A1 B1 is related to A2 B2. You take like this, A1 B1 is related to A2 B2. Now you need to check A2 B2 is related to A1 B1 or not. Okay. As you already taken this, A1 B1 is related to A2 B2. When A1 B1 is related to A2 B2, when B1 equal to B2. From this, you know that B1 equal to B2. Now you need to check A2 B2. Now you need to check A2 B2 is related to A1 B1 or not. When A2 B2 is related to A1 B1, when B1 B2 equal to B1, you already know B1 equal to B2. So it is very clear that these two are related to each other. So this relation is symmetric. I hope you are understanding. Transitive. How to check transitive condition? You take A1 B1 is related to A2 B2 and A2 B2 is related to A3 B3. Now you just check A1 B1 is related to A3 B3 or not. When A1 B1 is related to A3 B3, if B1 equal to B3, right? Now, as these two are related, what you will get? You will get that B1 equal to B. And you check, as these two are related, what you will get? You will get that B2 equal to B3. You observe from this, B1 equal to B2, B2 equal to B3. From this, you will get B1 equal to B3. You got B1 equal to B3. What you are trying to check? A1 B1 is related to A3 B3 or not. You are trying to check this, right? As B1 equal to B3, as these two are equal, 100% these two are related. So this relation is transitive. This relation is reflexive. This relation is symmetric. This relation is transitive. So this relation is equivalence relation. Statement 1, they are saying that R is a equivalence relation. Yes, statement 1 is true. You see this option, both statement 1 and 2 are false. They are saying this is wrong option. Both statements are true. We cannot say both. Statement 1 is true, statement 2 is false. Statement 1, see this option you can eliminate now, right? Now the question mark is there in these two options. For that you need to check statement 2. What is statement 2? It looks bit confusing but very easy. You see, S represents lines parallel to y equal to x. The set S represents a line parallel to y equal to x. What this set S contains? This set S contains order pair x comma y. Okay. When this x comma y belongs to x, when x comma y is related to a comma b. When x comma y is related to a comma b, what we know from this? We know that y equal to b. We just know that y equal to b. From this, we know that y equal to b. From that, how you will say that this represents a line parallel to y equal to x? This statement is false. Try to understand. This statement is false, right? So, statement 1 is true. Statement 2 is false. So it is clear that for this, the second option is the correct option. This is the question given in JEE examination 2025. The question is the number of non-empty equivalence relations on a set. Number of equivalence relations on this set. Non-empty. However, as set 1, 2, 3 is there, equivalence relation means it must be reflexive, symmetric, transitive. Empty set is not a reflexive relation. So this question we can take it as a number of equivalence relations also. To find number of equivalence relation, we have one trick. That number of equivalence relations we can find out from Bell's triangle. What is Bell's triangle? In Bell's triangle, first we'll write 1. Below to this one, you write one more 1. Okay, first you write like, now you add these two. 1 plus 1 is 2. You write that 2 here. Now whatever the last number you got, you write that number here. Now you add these two. 2 plus 1 is 3. Now add these two. 3 plus 2 is 5. Now whatever the last number you got, that write that number here. Okay, 5. Now you add these two. 5 plus 2 is 7. Now add these two. 7 plus 3 is 10. Now you add these two. 10 plus 5 is 15. Okay. This process will continue. For example, here last number is 15 is there. Na? You write 15 here. 15 plus 5, 20. 20 plus 7, 27. 27 plus 10, 37. 37 plus 15, 52. Here you observe this last element. From this only we will get number of equivalence relations. When set A contains one element, then number of equivalence relations is equal to 1. If set A contains two elements, then number of equivalence relations on that particular set is 2. Two equivalence relations can be formed. If set A contains 3 elements, number of equivalence relations is 5. Right? You observe this question. Here there are 3 elements are there. So number of equivalence relations is what? 5. So what is the right option? Third option is the right option. Very easy question, time saving question in JEE level. But only the thing is, to find number of equivalence relations, you must know about Bell's triangle. If set A contains 4 elements, number of equivalence relations equal to 15. If set A contains 5 elements, number of equivalence relations is 52. Like this, if we continue, whatever the number of elements are there in the given set, based on that, we can say number of equivalence relations. I hope you understand this solution. Domain, codomain, range of a relation. We already learned these things, but I just quickly revise these things and I'll explain how to calculate R inverse, and we do problems based on this, especially previous year question. Okay. Domain, codomain, range of a relation. First, I'll take one example. I'll take two sets, set A as 1, 2, 3, set B as 4, 5, 6. Suppose R is a relation from A to B. You know R is a relation from A to B means R is a subset of A cross B. You can see this is the relation I consider from A to B. Like that, so many relations we can form. I just consider one relation from A to B. In this relation, what is the domain of this particular relation? Set of all first elements of order pairs. Set of all first elements of order pairs in the relation is known as domain of that relation. So, what is domain of this relation? Domain is, see, this is not like a domain of a function. Domain of a relation is different. Domain is set of all first elements of the order pairs. 1 is there. So, domain is 1. Codomain. R is a relation from where to where? R is a relation from A to B. The set B is there. Set B is the codomain, right? That means 4, 5, 6. Codomain is, as R is a relation from A to B, set B is called codomain. Set B is nothing but 4, 5, 6. Next, range of a relation. Set of all second elements of order pairs in the relation. In this relation, whatever the second elements are there in the order pairs, they are known as range of that relation. What is range of that relation? What is the range of this relation here? Range of this relation is 4, 6. Okay. So, now you know how to calculate domain, how to calculate codomain, how to calculate range. See, R inverse. You observe here, R is there. Na? From R, we can write R inverse. If R is a relation from A to B, R inverse is a relation from B to A. Right? Writing R inverse is very simple. R inverse, you see, you observe R. From that only I am writing R inverse. R inverse is 4, 1. You look here, 1, 4 is there. Na? This is 4, 1. right? Here 1 comma 6 is there, na? This here you will get 6 comma 1. So you know from R how to calculate R inverse. Suppose R inverse is given, from that also you can calculate R in this relation. Okay. Now we do problems what way they are asking related to domain range of a relation. You observe this is the question given in 2025. S is a set. What is the set? Set of all natural numbers including 0. That means S is nothing but whole numbers. Okay, a relation R from S to R. Here do not confuse with this R and this R. This R is a relation R and this relation is from S to R. This R is set of all real numbers. And how the relation is defined? The relation is defined as order pair x comma y, and the x and y values satisfy this equation. X is from set S, that means whole numbers. Y is a real number. Okay, the sum of elements in the range of R. Here what they are asking, sum of elements in range of R. So first what I will do, I will find range of R. Range of R means, you observe here, this relation is x comma y, na? Set of all second elements is called range, na? That means I will find y values. I will find y values, sum of all elements at the end I required. First you take the given equation. What is the given equation? Log y base e equal to x into logarithm of 2 by 5. Okay. You observe this. This is like m into log a. In logarithms, basic differentiation, we learned that m into log a is logarithm of a power m. Right. So what this can be written as? This can be written as logarithm of 2 by 5 whole power x. This can be written like this. So this left hand side, it is log y base e. You observe here log y base e, here also log y base e is there. From this we can write directly y equal to 2 by 5 whole power x. I hope you understand. Here I got y values. Y is what? Set of all second elements in the relation. That means y will gives you range. What is x? X is whole number. X is from this set. So if you observe, when I put a x equal to 0, 1, 2, 3, 4, if we continue like this, you observe what are the y values you are getting. You put this x value here. What is y value you will get? 2 by 5 power 0, right? Put x equal to 1, 2 by 5 power 1, 2 by 5 whole square, 2 by 5 whole cube. It continues like this, right? What they are asking, sum of all the elements in range of R. That means they are asking you to add all these elements. What answer you will get, that is the answer, right? So here the answer is 2 by 5 whole power 0 plus 2 by 5 whole power 1 plus 2 by 5 whole square plus 2 by 5 whole cube plus, like that it continues. It's an infinite set. Please try to understand. S is an infinite set, right? Infinite elements you will get. If you observe this, this is in geometric progression. In sequence and series chapter, you will learn about geometric progression, right? You see common ratio 2 by 5 whole power 1 divided by 2 by 5 power 0 is 1. 2 by 5 whole square divided by 2 by 5 power 1 is 2 by 5. Common ratio is 2 by 5. Here first term is 2 by 5 whole power 0, which is same as 1. Common ratio R is 2 by 5. As it is in geometric progression and it is an infinite series, sum of infinite terms in geometric progression formula is S infinity. Sum of infinite terms formula is A divided by 1 minus R. What is A? 1 divided by 1 minus R. R is what? 2 by 5. If you observe this, 1 divided by 3 by 5, that equal to 5 by 3. So 5 by 3 is the answer. I hope you understand this solution. You observe this is given 2024. Interesting question. See, learning these relations is not like a watching movie. What I say, you just pause this video, try this problem your own, right? Later you check the solution. So many wonders will happen, right? See what they given here. Set A is 1, 2, 3, 4. R is a relation on A cross A. Usually R is a relation on A they will give, but here R is a relation on A cross A means R is a subset of A cross A cross A cross A, right? Okay, so that's why you see this relation how it came. One element A comma B from this, one element C comma D from this. R is a relation satisfying this condition. The number of elements in that relation. If we do this problem in regular method means verification method is difficult, right? One easy method is there for this. You will get an idea, just try to follow what I am saying, right? As A, what is A? A, B, as it is a relation on A cross A, this A, B are from this set A, okay. CD also from set A. What I will do here, 2a can be what? If a here 2a is there, na 2a can be what? If a is 1, 2a is 2. If a is 2, 2a is 4. If a is 3, 2a is 6. If a is 4, 2a is 8. 2a can be 2, 4, 6, 8. You see here 3b is there, na? What is b? B can be 1, 2, 3, 4. If B is 1, this is 3. If B is 2, 6. B is 3, 9. B is 4, 3, 4, so 12. I hope you are understanding. Now, what 2a plus 3b can be? What is 2a plus 3b can be what? That means 2a is this, 3b is this. 2 plus 3. 2 plus 3 is what? 2 plus 3, 5. It can be 5. It can be 8 also, 2 plus 6. It can be 2 plus 9 also, 11. It can be 2 plus 12, 14 also. Similarly, you take 4, 4 plus 3. See, 4 plus 3, 4 plus 6, 4 plus 9, 4 plus 12. It can be, right? 4 plus 3 is what? 4 plus 3 is 7. 4 plus 6, 10. 4 plus 9, 13. 4 plus 12, 16. It can be 6 plus 3, 6 plus 6, 6 plus 9, 6 plus 12. 6 plus 3, 9. 6 plus 6, 12. 6 plus 9, 15, 6 plus 12, 18. It can be 8 plus 3, 8 plus 6, 8 plus 9, 8 plus 12, 8 plus 3, 11, 8 plus 6, 8 plus 9, 17, 8 plus 12, 20. Okay. Now, same way, I'll calculate what are the possible values of 4c plus 5d. Right? These are the possible values of 2a plus 3b. I'll calculate what are the possible values of 4a plus 5d. Later, I'll check the common elements in possible values of this and possible values of this. From that, I'll get number of elements in this relation. Now, similarly, you try 4c can be what? 4c can be 4 into 1, 4 into 2, 4 into 3, 4 into 4. Okay. 5d can be what? 5 into 1, 5 into 2, 5 into 3, 5 into 4. 4c plus 5d can be what? This 4c plus 5d can be 4 plus 5, 4 plus 10, 4 plus 15, 4 plus 20. 8 plus 5, 8 plus 10, 8 plus 15, 8 plus 20. 12 plus 5, 12 plus 10, 12 plus 15, 12 plus 20. 16 plus 5, 16 plus 10, 16 plus 15, 16 plus 20. Now I calculated all possible values of 2a plus 3b, 4c plus 5d. Now you check the common elements in both. You see 14, 13 is common in both, 9 is common in both, 18 is common in both, 17 is common in both. How many elements are in common? You see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here you observe this 14 is repeated 2 times. Here this 14 is the combination of what? This 14 are combination of different. 14 is there here, 14 is there here also. This 14 we got when 2a equal to 2 and 3b equal to 12, right? The combination of 2a, 3b are different for this 14. See here, when 2a equal to 8, 3b equal to 6, then we got this. So here, if you observe, total 6 combinations are possible. So, how many elements we will get in this relation like a comma b comma c comma d which satisfies this condition is 6. Number of elements in the relation R equal to 6. I hope you understand this. And see, this type of questions frequently they are asking in JE. This is one of the PYQ. R is a relation which contains order pair x comma y. X and y are integers. It indicates that R is a relation on Z and satisfying this condition x square plus 3y square less than or equal to 8. Then domain of R inverse. You observe here, they are asking domain of R inverse, right? So, what way to calculate this? As they given x and y are integers which satisfies the equation x square plus 3y square less than or equal to 8. So, what I'll do, I'll randomly check by taking integers, right? So, here what I'll do, I'll take 1, 0, x value 1, y value 0, you write. This inequality holds good or not? 1 plus 3 into 0 less than or 1 is less than or equal to 8, satisfying. As here x square y square is there, I'll write possible negative values also. Minus 1 comma 0 also satisfies. Try to understand, right? Now I'll check for randomly for 0 and 1. I'll take x value 0, y value 1, right? 0 and 1. 0 plus 3 into 1 less than or equal to 8. As 0 comma 1 satisfies, as x square y square is there, 0 comma minus 1 also satisfies. Similarly, you just check that 2 comma 0. 2 comma 0 satisfies this, 4 plus 0, yes, 2 comma 0 satisfies this, as 2 comma 0 satisfies, minus 2 comma 0 also satisfies this. You check 3 comma 0 satisfies this, 3 square is 9. No, 9 is not less than 8. 0 comma 3 100% doesn't satisfy this, right? So here what they are asking, domain of R inverse. See, domain of R, if they ask, we will write this 1 minus 1 0 2 minus 2, that is domain of R. If R is a relation from A to B, R inverse is a relation from B to A. So domain of R inverse they are asking, then this values are the set of all first elements, R inverse. If R is x comma y, order pair x comma y, R inverse is y comma x. So set of all y values will gives you domain of R inverse. So domain of R inverse is 1 minus 1 0. This is the answer for this problem. Suppose if they ask domain of R, answer is 1 minus 1 0 2 minus 2, right? You see one more question which is given in previous year JEE papers. R equal to order pair x comma y, x and y are integers, x square plus y square less than or equal to 4, then domain of that relation. I request you to try this problem your own. Okay, later only you check the solution. I'll take x, y integers and I'll randomly check x square plus y square less than or equal to 4. I'll take x value 1, y value 0. Satisfying this or not? You check 1 plus 0. Yes, satisfying this. If 1 comma 0 satisfies, minus 1 comma 0 also satisfies this, because x and y are integers. X square, y square is there near, 100% satisfies, right? Next, 0 comma 1 you check. Yes, 0 comma 1, 0 comma minus 1 satisfies. 2 comma 0, 2 comma 0, 2 square is 4, 4 plus 0 less than or equal to is there near, so it is okay. So 2 comma 0, if 2 comma 0 satisfies, minus 2 comma 0 also satisfies, right? 0 comma 2, yes, 0 comma 2, 0 comma minus 2 also satisfies. If you check 3 comma 0, it won't satisfy this inequality, right? So what they are asking, domain of the relation. Domain of the relation means here domain of R they are asking, that means first values, right? Domain of this relation is 1 minus 1 0 2 minus, this is domain of the given relation.